2.5. This session is very important because we are going to learn how to solve for the zeros for a higher degree polynomial. Now, number one question, the fundamental theorem of algebra. This is the name of the theorem. Now, I would like you to pay attention not for the name. I would like you to pay attention on complex number system. So if fx is the polynomial of degree n, now for example, you have a polynomial fx and you have very high degree like 5x 100 take away 2x 99 plus what else? You can try. Okay, 3x take away 1, for example. And then you try to find the zeros. So you make a function make it equal 0 and try to solve for x when fx equals to 0. That's how we say zeros. Now, if you have 100 degree, how many solutions you are supposed to find? I think I mentioned this before. So, assume you are able to factor. And then let me pull out the file outside. So, assume you are able to factor to many factors. X, 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 X. When you are able to factor 100 of the factors. Okay, so and the solution A1, A2, A3 up to A100. Okay, A99. So if you are able to find 100 solutions, means you have 100 factors. Why I say 100 factors? Because every one factor you have x, x, x. So when you multiply the highest degree x, x, x for each one factors, you are going to have x to the 100 degree and multiply with 5, right? Then you understand by factoring to 100 factors, you are able to reach 100 degree. And then each factor, you make it equals to 0. You make each factor equal to 0. That's how you solve for the zeros. So x minus a1 equal to 0, you have x equals to a1. Second one, x minus a2 equal to 0, you have x equals to a2. And keep going on. X minus a100 equals to 0, x equals to a100. So total, you are able to find 100 solutions. So keep in mind, if the highest degree n equals to 100, then you're supposed to find how many solutions? 100 solutions. So this is very important. Now, it's understandable we're supposed to find 100 solutions, but the fundamental theorem, they talk about complex number systems. I want to talk about more detail for that. But before I keep going, let me erase those so we may have more space to explain. So we all agree, n degree we may have n zeros, but those zeros, those solutions are all real number or maybe imaginary solution. So I will give you an example from quadratic functions. If a function f of x equals to x squared plus x plus 1 equals to 0, how you find the zeros? If you try to factor by Fourier, then you are going to find a rational solution. But if you are not able to factor by Fourier, then most likely there's no you have the solution, not the rational solution. Rational solution means the answer is a fraction, but sometimes it's a square root, then you cannot factor by Fourier. If answer is 3i, then you cannot use factor by Fourier to find the answer. So let's try x equals to 2 times a negative b plus minus square root of b squared minus 4ac. Okay, so x will be negative 1 plus minus square root of 1 minus 4 over 2. X is negative 1 plus minus square root of 3i over 2. So if you have second degree polynomial, and if you are not able to factor by Fourier, then you may use quadratic formula to solve for the solution. And in these examples, we have two imaginary solutions. Two imaginary solutions, and basically we say complex solutions, because last time we learned if you have a real number plus an imaginary number, we call it complex solution. Imaginary solution is focused on only imaginary number, but actually, more precisely, we say this is a complex solution. Complex solution, you have a real number part, and also you have imaginary number part. Okay. So the fundamental theorem of algebra guaranteed if you have nth degree of the polynomial, then you are going to have n zeros, at least. Why we say at least? Sometimes we have duplicate solution, like if f of x equals to x minus 1 cubed, then it means x minus 1 times x minus 1 times x minus 1. So you have x equals to 1, 1, 1. You're supposed to find 3 solutions. When I was young, back in Taiwan, my teacher taught us 3 solutions is 3 solutions. Even though they are the same solution, you still need to write down 1, 1, 1. But here, we just say 1 solution, or we say only 1 solution. But when we say only 1 solution, it means let's duplicate 1 or 3 times. Okay? So no matter how many solutions you want to say, basically, you may factor to 3 factors. Okay? So in this case, if you have the duplicate same solutions, here we say only 1 solution. Therefore, if you have degree 3, we have at most 3 solutions. And here we say at least 1 zero in the complex number system. So complex number system include a real number plus 0 imaginary number, or include imaginary number or the plus together combination we call complex number. So if you have any degree of the polynomial, you are going to at least find one answer from the complex system. And I will say you are going to find at most 3, at least 1. Why at least 1? Basically, at my time, we say exactly 3, okay, or exactly n. But here, right now, we say if there's a duplicate, we consider is the same solution, then we say at least 1. Okay, at least 1, but at most 3. Now, let's go to number 2 question. Number 2 question basically related to number 1. Same thing I talked about. If you have nth degree, you may factor to n factors. So if you make each one make equal 0, that's how you solve for n solutions. Okay. So let me erase my marks here so you can read number 2. No confusion. Okay. So say if you are able to factor a polynomial to n factors, means this polynomial have an times x to the n degree, right? And plus something else. So the highest degree for this polynomial will be degree n. And because we are able to factor to n factors, therefore, when you make it equal to 0, when you make each factor equal to 0, so you make this one equal to 0, this one equal to 0, this one equal to 0. Any one equal to 0, you can make the function equal to 0. So you are going to have n solutions. And these n solutions may be real number answer, maybe imaginary number. And if combined together, it becomes complex. Okay. And the real number is also a complex number because we can say real number plus 0 imaginary number. Okay. Now we go to number 3. So how you decide how many zeros? The highest degree is 6 degree, right? So at most 6 zeros. And we may try to solve for the solution. So first we pull out the common factor. We both x cubed and this x cubed times x cubed. So you pull out the common factor and then x cubed minus 1 cubed. Let me give you the formula. A cubed minus b cubed equals to a minus b, a squared plus ab plus b squared. It's pretty easy to memorize because if you multiply 2 in the middle, then it becomes a perfect square formula. But this is not perfect square, so just 1. not 2. Okay, so A minus B, A minus B, and the rest will be plus. Another formula you should memorize is A cubed plus B cubed. If I change it to plus, then it will be A plus B. And the second one still A squared plus B squared, but here become minus AB. Okay. So here we try to use the first formula to factor. And then when we factor up to second degree, then we use quadratic formula to find answers. And x cubed means x times x times x, or you say x minus 0 times x minus 0 times x minus 0. So you have duplicated 3 zeros. We consider just 1 zero. That's why we say at the most how many solutions. But again, I say in my time, my teacher say we count same zero as 3 answers. So we have how many solutions here? We have 1, 2, 3, 4, 5, 6, plus and minus, right? So in my time, no confusion. 6-degree polynomial. I supposed to find 6 solutions as answer to my teacher. And right now it's more confusing because when you have duplicated solutions, you say this one. So right now we say at the most 6 solutions, but actually we only find 1, 2, 3, 4 solutions. And we find 2 imaginary zeros. I think it's better we say complex zeros, because when you have real number plus imaginary number, we call this complex zeros. Number 4. Now, start from number 4, we are going to learn a new method called rational zero test. Rational zero test, sometimes we call PQ test. Why we call PQ? P and the Q. Now, if you have a polynomial, for example, we learn how to factor by Fourier when there's a quadratic equation. We have 3x squared plus 2x plus 1, for example. Then you factor this polynomial by Fourier, F-O-I-L. Factor by Fourier is, we consider this 3 is f times f. This 1 is dust times dust. Okay, so second degree, you're supposed to factor to 2 factors and 3 times 1. That's the first time first. 1 dust times dust. Okay. And we try to adjust the outer product and the inner product. Outer product is 3 times 1. Inner product is 1. We want the middle term is 2. That's how we learn, right? So plus 3 minus 1. You factor by Fourier. You have x. Now, when we have higher degree, we use the same idea to guess solutions. Similar to factor by Fourier, we try error to figure out our solutions. So, when you see 3, you understand the first terms on the factor multiplied together need to be 3. In other words, these two numbers need to be the factor of 3. Let me give you another example to see. We can directly just use number 4 example. So this number, for example, let me rewrite. f of x equals to 2x fourths minus 17x cubed plus 35x squared plus 9x minus 45. Now you try to factor 2, because 4 degree, right? 4 degree, we try to factor 4 factors. Okay. Now you have x times x times x times x to guarantee x to the 4th degree. Now you have to think about, you have 2, and try to factor 2 to 4 factors. So I will guess 2 times 1 times 1 times 1. That's only possible, right? But when we talk about 45, then there are so many possible choices. Maybe 1 times 1 times 1 times 45, maybe 3 times 1 times 1 times 15, maybe arrange the location, right? There's so many possible choices. Maybe 3 times 5 times 1 times whatever, 3, right? Or 9 times 4 times 1. So many possible choices. But you understand, the last term are the factor of, I say, q, the factor of q. And the first term, a coefficient, first coefficient will be the factor of p. So therefore, when we try to factor, we use the coefficient p to decide the coefficient for the first term, the first item. Okay, first term. And then we use the factor of q to decide the last item. Okay, so let me erase those marks, and we just did one example here. Okay, so for example, if I don't know if this is right or not, but pretend it's right, then we can do plus, minus, or whatever. Okay, pretend that's right. Then when you solve for 0, what happens? When you solve for 0, you are going to have 2x minus 3 equals to 0, x plus 1 equals to 0, x minus 1 equals to 0, x plus 15 equals to 0. Okay, and how you find the solution? Pay attention here. Let me change color again. This is 2, right? This 1, this 1, this 1. And the color here, you have 3, 1, 1, 15. Okay. So your solution will be x. Your solution is x. And what's on the numerator? 3, 1, 1, 15. Maybe positive, maybe negative. We don't know yet. I'm just guessing, right? And then the denominator will be the yellow color. Okay, and keep in mind, remember, we had so many different choices, not just one choice. So the denominator is supposed to be the factor of 2. And the numerator is supposed to be the factor of 45. Now, factor of 45, not only this choice, maybe positive negative 9. Let me change color. Nope. So it's possible we have more choice. Positive negative 9, positive negative 5, right? They are all the possible factor from 45. So this is our, we call the PQ test from other book, or we say rational zero. Why we call rational zero? A fraction. Fraction means rational. Okay. So again, let me erase this. So this factory is my guessing, not necessary to be correct. So how can we guess right? That's a problem. So many possible choices, right? If you have 45 for Q, definitely your numerator won't be the number of 2 or 4, something like that. But still, many possible guessing, many possible choice. So how we decide which one is the right choice? So first, what we have to do is we try to list all the possible choice of our solutions. Now, the first term is possible to be the factor of 2. So maybe positive 1 or positive 2. Okay, I put the positive here. And the numerator of your solution came from the last term 45. So 45 maybe 1, 3, 5, 9, 15, 45. And when the denominator you choose 2, the possible choice, you still have numerator for the same possible choice. So this is all possible zeros. Now, let me read the question first. Use the rational zero test. So it's this test to list all the possible rational zeros. So I list all the possible zeros. On the homework, you may want to say positive negative 1 over 1, positive negative 3 over 1, positive negative 5 over 1, positive negative 9 over 1. You don't need to write down over 1, positive negative 15, positive negative 45. And then keep going. This part, positive negative 1 half, positive negative 3 half, positive negative 5 half, positive negative 9 half, positive negative 15 over 2, positive negative 45 over 2. So you list all the possible zeros. That's first part. And verify that the zeros are shown on the graph. They show you the graph, and those graphs you want to pay attention on the x-intercept. Why x-intercept? Because x-intercept means y equals to 0. Y equal to 0. What's y? Y is f of x. So when the function equals to 0, you are looking for the zeros. So when x make a function equal 0, those x are the zeros. Therefore, you're supposed to find, you can use the x-intercept. The x-coordinate is your zeros. And from the graph looks like a -1. This number is 1, 2, 3, 4. This is 1, right? So this is 3/2, 1/2. This number is 3. This number is 5. So the coordinate 5, 0, 3, 0, 0, right? Now, -1 is here. 3/2, 3/2. 3 is here. 5 is here. So if you are able to list all the possible zeros, and then pretty soon I'm going to teach you, if I don't give you the graph, how you guess correctly. You only choose 4 solutions. You don't give the teacher so many possible answers. Okay? So teacher maybe first time ask you list all the possible zeros, but pretty soon we are going to ask you, give me exactly the right zeros. If there's only 4 zeros, then only give me 4 zeros. So let's go to number 5. Number 5, first we try to list all the possible zeros. 30, and this means 1. Okay. Since denominator is just 1, so we only worry about the numerator. You factor 1 times 30, 2 times 15, 3 times 10, 5 times 6. They are all 30s. Now, very important, how do we know which one is the right one? You only supposed to choose only 3 solutions. And remember, if that's a 0, you plug in, you're supposed to make it equal 0, right? Therefore, I always try the smallest possible. I try 1. So I try 1, I plug in 1, 1, 1. 1 minus 19 plus 30 is not a 0, so I don't choose 1. How about I choose -1? I will choose the smallest possible number, okay? -1, negative become plus. -1 plus 19, okay, and then plus 30 won't be 0, so you don't choose that. Then you try 2. Now, you may always plug in h of 2 equal to 0, yes or no. H of -2, you want to make sure it equals 0, yes or no. And there's another way. Remember, if you divide by x minus 2, if the remainder is 0, we call this a remainder theorem. We learned that from the last semester. So that's the video. That's the section. Let me review the concept for you. So the remainder theorem is talking about if a polynomial is able to be factored x, 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 and x minus something plus something, okay, to factor. And when it equals to 0, you want to solve 0, then either this factor equals to 0, or this factor equals to 0, or this factor equals to 0. And then we try to solve for each factor. And if you are able to factor, means, for example, if I guess x minus 2 is one of the factors. What it means? Means h of x divided by x minus 2 need to be evenly divided to the rest of 2 quotient. and no remainder. So the remainder theorem telling us if you try to test a zeros, then this zero, when you divide by the factor, supposed to the remainder is 0. Okay, so I'm going to show the alternate way. You may plug in h2 and make it equal 0 to see it's equal 0 or not, to decide x minus 2 is a factor or not. But we can also use synthetic division to divide. So I divide for you, show my work here happen to be 0. So what it means? Means x minus 2, yes, is one of the factor for this polynomial. So, and this will be the quotient. So let me erase those marks and rewrite. You can see better, understand better. Okay. So it means this one can be factored to x minus 2. And what's the quotient here? X squared take away 2x minus 15. This is x squared, not a minus, it's plus 2x, right? Plus 2x minus 15. And the remainder is 0. When remainder is 0, we just don't need to write down that. Okay, so after we have find the first factor, we need to keep going, x minus 2, and we try to factor the quotient. Are we able to factor the quotient by 4 here? Yes. 3 times 5, right? And we have plus, minus, yes. So, did I factor correctly? Wow, I factor wrong in my previous work. Okay, so this is the correct one. So after I factor, then I make this one equal to 0, this one equal to 0, this one equal to 0. So negative y positive 3. Okay. So okay. So right now I'm going to end my first part of the video on question 5, and start from question 6. I'm going to have a new video. So see you next time. Bye bye.